as functions practice work. Um, so here we have questions 1 and 2 assigned, but there's probably not enough room here, so I'm going to write my answers over here. All right, so question 1 asks us to use words to describe what each function does to an input. And this might be easy to overthink, but so we'll look at f of x first. So what does this function do to an input? Well, the x here represents the input, the value that's being put into the function, and it's being multiplied by 3 here. So for example, if I had f of 5, well, that would give me 3 times 5, or 15. In other words, we take my input, and it makes it 3 times bigger. So for this function, all we really need to do is say that the function multiplies the input by 3. And you might be able to think of a more condensed way to write that. I'm going to write it nice and long so that people understand exactly what I mean. All right, for part B, pretty similar, except instead of multiplying, we see the input is being divided by 2. We say divides the input by 2. Okay, pretty simple. For H, this function takes an input and, well, it looks like it multiplies it by 10. And then after that, it takes away 25. And the order is important here. We use BEDMAS, which means multiplication before subtraction. So first it multiplies the input by 10. And then it takes away 25. Then it subtracts 25 from the product. Product is the word for the answer to a multiplication question. Okay. Lastly, D. So it looks like this function does 3 things to an input before it's finished. So we'll go through an example. Let's take an input value of, let's say a quarter. Let's say a half. Okay. So we put a half into this function. Let's just see what happens here. So we get 4 times 1/2 squared plus 6. Again, following BEDMAS is going to become really important. We have brackets, but there's nothing we can resolve within them, so we move on to the exponent step. The exponent step says we've got to square 1/2, meaning 1/2 times 1/2. So the next line might look like 4 times 1/2 times a half. Half of a half is a quarter. Okay, that's the exponent step done. Moving on to the multiplication step, 4 times 1/4. There's a couple of different ways to look at it, but I think it was Emma earlier in the week who recognized that when you multiply something by its own denominator, those just cancel out. So it actually becomes just simply 1 plus 6. And then we can move on to our addition step. And it becomes 7. All right, so what happened here? Well, in order, we saw that the first thing we did was the function squares the input. Then, maybe I'll write this as bullets, then multiplies the square by 4, and then adds 6 to the product. Okay, so let's move on. We're going to be using these functions for part 2. 2a says, okay, using the same functions in question 1. In other words, if we're talking about f, this is the function that takes the input and multiplies it by 3. That's the f function. Okay, so this is all pretty much review to you guys, I think, at this point. We're going to get into a few more challenging ones in a second. So how I approach this question is I start with my f of x function. And then I say, okay, my input in this case is 25, so I'm going to rewrite this function. 25 replacing x. X represents our input here. And I'm going to input a little multiplication because there was an implied multiplication between the 3 and the x. And so I say, okay, f of 25 equals 3/25, which is 75. Okay, moving on. B, we get g of x. Well, g was the function that divides our inputs by 2. So we could say, okay, well, g of negative 18, as a number, it's going to be negative 18 over 2. And we could say then that g of negative 18 really simplifies to half of negative 18, which is negative 9. And with really simple functions like this, if you don't want to go through all these steps, you definitely don't have to. I'm just trying to write things out more explicitly, but I would not be surprised if several of you feel really comfortable just looking at that and writing the answer, doing all the work in your head. And that's great. You should do that if you feel comfortable doing that. Okay. So then we move on to C. 2C says we have h of x. And h of x said we took our input, we multiplied it by 10, and then we subtracted 25. All right, let's take a look what happens when we use 2/5. H of 2/5 is an input. Okay, well it says I'll multiply 10 by 2/5. I'll take away 25. Now, we can multiply these through the long way by saying 10 times 2, and that's all over 5 because it's 10 over 1, and that's fine. And then simplify the fraction from there. However, I can see that 5 is a factor of 10 and is a factor of 5. So I'm going to just divide diagonally. So that's a 2. I divide 10 by 5 to leave 2, and I divide 5 by 1 to leave 1. I'm actually going to write the intermediate step out here just to make it extra clear what I just did. But usually I would probably skip this step. And then we can say, okay, well really what we're looking at is 2 times 2, which is actually just 4. So h of 2/5 is 4, take away 25, which is, what is 4 take away 25? That's negative 21, right? Yeah, negative 21. All right. Moving on to D. Okay, we have the y function, y of negative 1.5. And the function says, oops, I usually was starting with the original function. Now, I guess I'll skip that this time. 4 times negative 1.5. We're going to square that value. We're going to add 6. Okay. So this question requires us to make a choice. We're dealing with a decimal that could actually probably be easily written as a fraction. And we're going to have to make a choice about whether we want to continue working in decimal or express a fraction. Good rule of thumb says that if we're given a decimal to begin with as an input, it's nice to retain that level of expression. And so we're going to try and stick with decimals and express our answer as a decimal. If you find it's easier to turn into fraction part way, really, that's fine. But a good practice is if you're given decimals to begin with, give decimals as a final product in the same way that as we were given a fraction here, and if our fraction input led to a fraction output, we would have kept it as a fraction rather than a decimal. Okay, so let's keep this as a decimal. Okay, so we got y of negative 1.5. The first thing we did was square, so we're going to square 1.5. And so I might just do that quickly because I know it's probably a pretty quick multiplication. 1.5 times 1.5, 5 5s is 25. And 5 times 1 is 5, plus 2 is 7. And then I multiply 1 by 5 and 1 by 1. I get 1, 5, and I would add those together. So I get 5, 12, I'll carry the 1, and I get 2, 2.25, because I have 2 decimals here, so my answer will have 2 decimals. And so that means that really 1.5 squared is 2.25. And that's the same for negative 1.5 squared, because negative 1.5 times negative 1.5, well, it's going to give us a positive value. Okay. Oops, I don't need that because we already squared. The next step is we are going to be multiplying that product by 4. I could do that the long way, but maybe I'll be a little creative here. I know 4 2s is 8, and I know 4 0.25s or 4 quarters is 1. So I think I can say that's 8 plus 1, so that's 9 plus 6. And 9 plus 6 is 15. So y of negative 1.5 is 15. Okay. So we'll move on. We'll take a look at 2e. All right, 2e asks for our f of x function, which multiplied things by 3. So our input in this case is a binomial. So we want to be careful when we do this. 3 is being multiplied by the entire input. So it's really important to put brackets around the input. To imply that this 3 is being multiplied by both, it would be easy to just say we should write it like that. But this implies only 3 is being multiplied by a and not by the 3. Okay. And we would want to distribute, actually multiply the 3 through, and so that gives us 3a plus 9. Okay. We've got our g function again. Our g of x was the one that divided things by 2. So g of negative 3/4 is going to be half of negative 3/4. So negative 3/4 all over 2. Well, there's a few different ways to approach this. I think because I've got a bit of time, I might just make an argument for this long way, then talk about maybe a shorter way to do this. I could really express this as an idea of negative 3/4 divided by 2 over 1. And so I could say, okay, negative 3/4 divided by 2 over 1. Using my division of fraction rules, I could say that we always want to flip that and turn it into a multiplication. So it's 3/4 times 2 over 1. And, well, then I can just, I could multiply straight through, but actually I see there's some common factors here. So I can reduce the 2 and the 4 by dividing them both by 2, leaving a 1, and a 2. So I end up getting, why does this feel wrong? Oh yeah, I can see why it's wrong. I didn't actually flip it. Yeah, ignore that. Okay, cool. So let's try that one more time. All right, so we get to multiply and also flip the second term. All right, that's looking a little better. Okay, so we don't see anything that can reduce diagonally or up and down. So we'll just multiply across. 3 times 1 is 3. 4 times 2 is 8. Now, dividing a fraction by 2 really has the effect of multiplying that denominator by the value 2. So 3/4 actually becomes 3/8. Okay. Negative 3/8. Okay, moving on to G. We've got H. Okay, we've got a binomial input again. And so, what's our H function? Oh, our H function multiplies by 10. And again, these brackets are really important here. And then we take away 25 from the total. So, okay, what are we going to do? We're going to say, okay, well, h of x plus 5 is 10x plus 10 5s, 10x plus 50, take away 25. So, when all said and done, h of x plus 5 is, well, we group like terms here, 10x plus 25. Okay, moving on to h, we've got our y function. What was our y function again? Oh yeah, it squares things and multiplies them by 4, then adds 6 to the product. Okay, our function also takes in a binomial input, but this time we have to square it. Oh, I'm writing totally off screen. All apologies. So all I've done right here is I've written the original y function, and then I put as an input x minus 1 and x minus 1. All right. Now, we want to be careful here. What we don't want to do is distribute the squared. So just to be clear, x minus 1 squared is not x squared. Take away 1 squared, although it's tempting to want to do that, is actually a stealth expanding question. To be squared means to be multiplied by yourself. So that means x minus 1, we're going to multiply it by x minus 1. Okay, I'm actually going to write that out within the question. So what this really means is x take away 1 times x take away 1, and then we'll add 6 to the total there. Okay, now we have really 3 things being multiplied together. I could multiply them in any order I wanted. I could multiply the first 2, or I can multiply the first one times the last one, but I think I'll multiply these 2 together to get the big expanding step out of the way. So I'll leave the 4 and I'll say, okay, just to remind you guys, we multiply the x into both of these terms, and then the negative 1 into both of these terms. So x times x is going to give x squared. X times negative 1 is negative 1x. Negative 1 times x is the same, negative x. And negative 1 times negative 1 is 1. Don't forget the 6 at the end. All right, and we move on. We say, okay. We have 4. We'll multiply it into that. Oh, actually, maybe we'll simplify first. X squared, take away 2x. Those are like terms, plus 1. And then we add 6 to the total. All right, that's the squared step over with. And, oops, so we're subtracting 1, not adding 1. So we'll multiply the 4 in at this stage. We get 4x squared, take away 8x plus 4. And then add 6 to it. And then we have these like terms, which would give us 10. And then we're done. Okay, so 4x squared, take away 8x plus 10 is our totally simplified answer. That was a bit of work. All right, so the rest of the questions are maybe a little bit more challenging. They require us to go backwards a little bit. Okay, so this one asks, okay, so for what x does f of x equal 7? Or what input for the f function gives an output of 7? Okay, so f of x is always 3x, and I know that I'm looking for an output of 7. I might replace f of x with that 7. And when I'm looking for the x, I'm going to just isolate it algebraically, which means as a multiplication, I'll do the opposite. Divide each side by 3, and I get x 7/3. That's pretty straightforward. Let's see how things can become a little bit more engaging. So my g function, g of x is x over 2, and then my new input is pi over 2. So my new output is pi over 2. So if pi over 2 is equal to x over 2, well, then what's x? Well, in order for these two to be equivalent, the only possible identity for x is pi. Because no other number could make this equivalent to pi over 2, or half of pi. I could make that argument algebraically as well. I could multiply by 2 on both sides, canceling these guys out, and I get x is 2 times pi over 2. These cancel out diagonally, leaving us with pi. Okay. So on to k. Okay, so k, what's our h function again? Oh yeah, it is k, no, h of x is equal to 10x take away 25. And my k function says my output is 65. Okay, so to isolate x, I'll first get rid of the thing on its side that's furthest away from it, which would be this 25. So I'll add 25 to both sides. And that gives me 90 on the left, 10x on the right, and then I will divide by 10, and I get 9 is x. Okay. L, okay, for L, we do it using our y function again. Our y function's a bit of a beast. Y of x is 4x squared plus 6. My output is 406. 406. 4x squared plus 6. Again, we want to start with the thing furthest away from x to get rid of it. So we got to get rid of this 4. We got to get rid of this squared term, and we got to get rid of this 6. So this is the last thing we would do in BEDMAS, so we consider it furthest away. So we'll take 6 away first. So that gives us 400 on the left and 4x squared on the right. Then we want to get rid of the 4. So we'll divide by 4, divide by 4. And that leaves us with an x squared on the right. And a quarter of 400 is 100. And you may just see that the number that you square to get 100 is 10, but if you didn't, you could do an algebraic step. You could square root each side. That undoes squaring. It's the inverse operation, and that leaves us with the square root of 100, which definitely is 10. All right, just a few more. So for m, we've got function f of t equals, our original function f of x is equal to 3x. Now this function introduces a new letter. It says, well, what if f of t is negative 12? So what's important to recognize is that this variable is just a placeholder. It is not specific. As we are fully able to replace an input symbol of x with an input symbol of t, or a little drawing of a Christmas tree, or a smiley face. They're really just symbols at the end of the day. So it's perfectly fine for us to refer to t. So I'm going to just rewrite this as f of t is equal to 3t. And if that's true, what output gives, what input's going to give us an output of negative 12. So f of t, negative 12. And then I just divide by 3. I find t is negative 4. Okay. For g of r, it's going to give us 24. Sorry, that's the original statement. I should start with g of x is x over 2. And so that means g of r is the same thing as r over 2, as we said earlier. We can do a simple transposition there. And then we have this output. It says, well, what if g of r is 24? So 24, r over 2, we got to isolate r, so I would multiply by 2. And I get 48 is equal to r. All right, 4 more. I think I'll keep them on the same page here. So let's go up to O. So O refers to our h function, which says h of x is equal to 10x take away 25 as a function that multiplies by 10 and takes the value 25 away. And if h of c is 4.5, so that means first it might help to rewrite this as h of c. This is perfectly fine. We can just transpose a letter and then say, okay, well, 4.5 is our output. The question is, what input gave us that? And okay, so this is going to involve a few steps. We'll add 25 first. And we find that 10c is equal to, well, that's 29.5. Great, and I'll divide by 10. And when you divide by 10, a little trick is you can move the decimal place over 1. So actually we could just say that 2.95 is our value for c. That's the input. That gives an output of 4.5. And again, if we ever wanted to test that, we could say, okay, well, what if, with my h function, I put in 2.95? What comes out? 10 times 2.95, take away 25. Let's just test it. First thing I would do is multiply by 10. So when you multiply by 10, you can move the decimal over once. So make it 29.5. Take away 2.5, pardon me, take away 25. we find, yeah, we get 4.5 as an output, which is the one we were expecting. Okay. P. So we got our y function again, which was the function y of x is equal to 4x squared plus 6. All right. And then we say, okay, well, for the y function, I can replace that with a k. Replace my x with a k, and that is all right. Our input here, pardon me, our output, y of k is 42. And so as we saw in question L, we have this order of operations to isolate k, and the first thing we want to do is get rid of 6. And we get 4k squared on the right, and what is that, 36. We divide by 4 on each side to isolate k squared. That leaves us with 9, and then we square root each side. And we find that k could have a value of, oh, interesting, I just realized there's something I overlooked. K could have a value of positive or negative 3. And that's actually true for L as well. We could have positive 10 or negative 10, both giving that same output as a result. I overlooked that very slightly. So I'm going to put a little asterisk here. So C2P. Okay. And so our value could be negative 3 or positive 3. And the idea here is if the opposite of squaring technically isn't square rooting, it is, we call it the principal square root. So we gotta always remember that a positive or a negative value of k could satisfy this equation. Positive 3 would satisfy it, and negative 3 would satisfy it. Okay, almost missed that. All right, so we'll do one more. Okay, so what if for f of 2n, okay, I should start by writing out f of x. For q, f of x is 3x. Okay, and then we're asked about the function f of 2n. So let's consider what f of 2n would look like. It would look like 3 times 2n, which could actually be rewritten, f of 2n is the same thing as 6n. All right, and now we know that f of 2n is the same thing as 20, the output for the input 2n is 20. And then to find out what n satisfies this, we would divide by 6. We get n is 20 over 6, which is the same thing as 10 over 3, simplified. All right, so for R looks a bit heavy. So I think I will, even though I don't want to use an extra page, I think I will, just to make sure I'm not cramming anything in. So the last question refers to 2R, and we're looking at the h function. So h of x, we remember, is 10x take away 25. So what if we put as an input to this function 3w take away 5? What would that look like? Well, it would look like 10 times 3w take away 5 minus 25. And I could simplify that, because it's a little messy right now. And I would say, okay, there's another way of saying 30w take away 50 take away 25, or 30w take away 75. And that's h of 3w minus 5. Okay, so if that's all equal to 12, 12 is the output. Question is, what w will satisfy that? So to find that, we're going to add 75 to both sides. It gives us 87. That's equal to 30w. Then we'll divide by 30, and divide by 30. And we get w is equal to 87 over 30. Does that simplify? Well, my first thought was that 87 is a prime number, but when I look at it and I add 8 plus 7, I see that it gives me 15. 15 is divisible by 3, therefore 87 is divisible by 3. So I think about it a little harder. What do I multiply by 3 to get 87? Well, I know to get 90, I must multiply 30 by 3. This is a little less, so that must be 29. So if I divide each of these by 3, I will get 29 on the top and 10 on the bottom. Okay, and that is that. Please let me know if you have any questions about any of those guys, because I think those are some pretty basic function skills that we're going to really need in order to take our function ideas into the grade 12 level.